So hi everyone, this is a problem of linear algebra on linear dependency and independency. Okay, so basically this problem tells us that if three vector w1, w2, w3 are independent vectors, then we have to prove that v1 equals to w1 plus w3, v2 equals to w1 plus w3. Okay, I think I made some mistake. Is it or not? v1 shown w2 hours 2, it will be w2, sorry. So we have to prove that v1 equals to w2 plus w3, v2 equals to w1 plus w3, and v3 equals to w1 plus w2. So are also independent. So we have to prove this vector, this vector, this vector are also independent if these three vectors are independent. So let's solve this problem. I'm cleaning the boards to solve the problem. Okay, so at first we will clear one concept of linear algebra, that's if some vectors are linearly independent, then they will fill up this condition, that suppose three vector w1, w2, w3 are independent, then some coefficient x, w1 plus some coefficient y, w2, and some coefficient z, w3 equals to 0 only when these three coefficient equals to 0. If here x equals to 1 and something y, something equals to z give us 0, then these three vectors are not linearly independent, they will linearly dependent. So since our three vectors, we know already that we have these three vectors are linearly independent by the convention of our question. So we can assume that, or we can consider that these three coefficients are must be equals to 0. Okay, so here I clear a simple concept of linear algebra to solve the problem. Okay, then what we have got, we have gotten that the three vectors are v1 equals to w2 plus w3, v2 equals to w1 plus w3, and v3 equals to w1 plus w2. So now we will make these three vector, we will write this three vector as a linear combination. So we consider three constants, c1, c2, c3. Okay, so then we can write it as c1 v1 plus c2 v2 plus c3 v3. Okay, then put the value of v1, v2, v3 here, then c1 w2 plus w3 plus c2 w1 plus w3 and c3 w1 plus w2. So then we multiply the constant part with the w1, w2, w3, then we get c1 w2 plus c1 w3 plus c2 w1 plus C2 W3 plus C3 W1 and C3 W2. Now we will take the any kind of any kind of W1, W2, W3 from you will see that here the every W1 or W2 are repeated, like here is W2 and also here is W2. We can solve this problem with in a multiple way, but I am solving it in a considering one way. Okay, so take the common term in with each other, like here is a W1, here is a W2, and here is a W3, and here are also W2, W1, W3. So take this beside take this W1, W3 into a bracket. Okay, so W1 C2 W1 plus C1 W2 plus C1 W3, and also C3 W1 plus C3 W2 plus C2 W3. So these are our we have written this vector like in this form. Okay, now what we have learned earlier of this problem, we have learned that since W1 and W2 and W3 are three independent vector, for this reason for any combination of C1, C2, C3 or any kind of constant part with W1, W3, it will not give 0 until we put C1, C2, C3 equals to 0. So what is the reason behind it? Since W1, W2, W3 are our independent variable, so that's why we can say that. And how we get this line? From where? We get this from this part of this math. So we can say easily, since these are not we can say easily that this part of our mathematics, it will we will get 0 only this time when C2, C1 and C3 equals to 0, and that means this is a linearly independent. These are linearly independent. So that makes sense about that. Since this is linearly independent, so that's why this is also linearly independent. And repeated my speech again, that we get this line from this line, and we see that these three vectors are linearly independent. So and since these vectors are linearly independent, we will get 0 from this line. It will equals to 0 only when this constant part, this coefficient are equals to 0. Since we get this line equals to 0 only when this coefficient equals to 0, and we get this line from this line, that means these vectors are also linearly independent. So that's the question told us about to prove. So thank you everyone. If you don't understand, please watch it again.